Welcome back to the Tech Podcast. So today we are going to cover a really interesting and useful topic, system design. And before we dive deeper into our discussion, could you give us a brief overview about your background, your experience in tech?
Sure. So I think at this point, I've built or helped build projects in various different industries. I started out working at a hospital in like a research lab, and then moved to a trading firm where I built out some of their tools, and then worked at Bloomberg for a while, working on
Mm.
financial technology, a query engine there. And then I recently left a job at Google Life Sciences, where I was leading a couple teams there. So I've had some experience on the back end and the front end, but I recently left to work on a system design blog for full time, basically.
Wow, that's amazing. Where do you live?
I live in upstate New York right now.
Cool, cool. Yeah, I'm in London, so that's great. Nice to meet you, and thank you for joining the podcast.
Yeah, of course.
And
Thanks for having me.
tell me more about your blog and what's the goal of your blog?
Sure. So I think system design blog's purpose is pretty simple. I think there are a lot of senior engineers and staff engineers and candidates for various companies that just want help in system design in terms of resources. I think right now the resources aren't amazing. If you think about coding, which comes to mind when a lot of people think of preparing for interviews, coding has so many resources. You've probably heard of like Leak Code and like cracking the coding interview and all of these books. I think maybe because senior engineers tend to do system design, there's kind of maybe this expectation that they're already very good at it, and so maybe there aren't as many resources. I don't know exactly what the reason is, but whenever I look at it, I don't see too many great resources. I think there are some resources that target high level design. There are some resources that are more like reference books and they target low level design. And I think it makes it very hard for senior engineers to kind of come up with an efficient, effective, kind of time boxed way to prepare for their system design interviews. And so my goal with System Design Blog is to kind of offer that to engineers and just kind of save them time, save them stress by giving them high quality material.
Yeah, that's amazing. I talk with lots of people who work in quite fun companies and different companies in tech. It doesn't matter. And everyone was struggling with system design. So everyone just, oh, it was horrible. Definitely I'll put the link into description box so everyone can follow it and join your blog.
I think I just saw so many people having problems, and I was getting a lot of requests to give mock interviews to people. I mean, like dozens and dozens of engineers just like wanted help. I saw a lot of promise in the idea of what I was building. I think before that, I had tried various ideas and various app ideas that I thought could be promising, but then over time, I realized I wasn't sure of either the demand of the idea or I just wasn't having fun building it. But I think with the system design blog that I'm working on, it almost didn't feel like work because it seemed like something people wanted. There was a time where dozens of people were contacting me to mock interview them, and then I thought, well, I don't have that much time to like mock interview everyone, but maybe if I
Mm.
create a resource, then they can kind of look through it on their own time. So I think the short answer is I saw a lot of need for it, and so that kind of drove me to work, like whether that's on the weekend or like after work. And you're coding all day at work, so coding even after work is a little frustrating. But if you if you truly think there's an impact that's going to be made and it's interesting to you, I think that's what pulls you through to do it.
Yeah, I got it. That's interesting. So there are lots of people who want to know more about system design. They're looking for additional information. They ask you to share your knowledge, right? But what about you? Do you have passion to system design, or your passion is to share your experience with different people and yeah, provide them support?
Oh, I love system design. I love mentoring junior engineers. I feel like on my last team, I had like 12 engineers that were all kind of junior to me, and I spent my like full-time job was basically looking through their designs and commenting on what could be better, what kind of
Mm, cool.
um, what the best practices are and things like that. So I think it's a combination. I really like designing systems. At Bloomberg, we had a query language which had its own like query engine that connected to so many different data sources, and it had such an interesting system design component, and it kind of got me hooked on it. And then as I grew as an engineer, I just like started reading papers and reading books, and it's just very interesting to see how people go about designing different kinds of systems. Designing Google search engine is very different from designing like Netflix, which gives you videos. So I think the answer is like, yes, I like system design. I also like talking to people about it.
Okay, cool. I'm happy to hear it. And let's dive deeper into it. So, can you provide, please, maybe some like great examples of system design?
I guess if you haven't read about a system, you wouldn't necessarily know all of the tricks and tips of like how to kind of build out that system. But for example, if you take something like Netflix or just a general video streaming platform, a junior engineer might say, well, okay, there's a server and the server has a big video file for a movie, and somehow you send that video file to the client, right? Whoever wants to watch the movie. And maybe you send a request and like somehow it all happens. But I think if you want to really excel at system design, you want to know how the API would kind of work, and you would also want to know how the movie files are actually arranged, and you want to actually just understand fully like what is the experience. So for example, you there's this idea of adaptive bitrate resolution, which I think is like a pretty cool concept. It's, I'm sure when you have poor Wi-Fi, you kind of see grainy video. And when you have, great Wi-Fi, you see very high quality video. So that's a feature, not a bug. A software engineer at some point decided, okay, well, if someone has poor Wi-Fi, we still want them to continue getting their video, but we can't send as much information because they have poor Wi-Fi, and so let's just reduce the resolution. So someone thought of that before they started coding anything, and then they started coding and building around it. And so the way you do it is, if you're a producer or director or whatever at uploading your movie to Netflix, or maybe you're just a user using YouTube and you're just uploading your video to YouTube, in either of those cases, what happens is your video will trigger some kind of process. It enters some queue, and then what happens is you'll have these various processing queues that will create like a 360 pixel version of your video, a 1080 version, et cetera, et cetera. And as someone pulls up your video in sort of their browser, you will pull from the proper queue based on like what the Wi-Fi is. So let's say you're in, poor Wi-Fi setting, then you will pull from like the 360p queue. And then maybe you actually just take your computer and move to like some higher, like better Wi-Fi location, maybe just like across the room. And then now your computer is able to actually pull from the 1080p PQ. And so you can kind of dynamically adjust the bit rate. And well, the bit rate is changing because the Wi-Fi bandwidth is kind of changing. But now, because you built your application to cater to different Wi-Fi speeds, now you can kind of give people a better experience depending on what resources they have, if that makes sense. So that's I think one kind of cool application that if you just show up to a system design interview, you probably wouldn't know to kind of build that. But if you read about it, because it is a pretty cool thing to read about, you would then think about it. If someone said, oh, build Netflix, then you would think, oh, adaptive bitrate resolution and bit rates and compression, like these things are important for video streaming applications. And there are similar things for like search engines, and like if you want to build like an Uber type app, there are certain tricks there. So I think hopefully I answered the question. I might have just been rambling, to be honest.
Yeah, that's a nice example. Thank you very much. And if you're talking about like how the system design evolves, so we have right now different practices. Maybe you can share some, maybe not the best, but the recent like approach at trends in system design.
So I think it's kind of interesting because I'm on like the prep side. I'm just trying to like talk to engineers and get them prepared for their interviews. So there's like always this distinction between the actual system design that is happening in the world, and that's like what engineers are doing. That's the entire field of software engineering. I don't even know if you would call that system design. It's just all of software engineering. I think interesting trends there are probably like ChatGPT for sure. And like one characteristic of system design is correctness. You want to make sure that given any given input, you want to produce the correct output. That's very, very difficult with ChatGPT because I guess if you've used ChatGPT, you just don't always know, the user could input anything and you have to make sure there's some safe, reasonable answer that's being provided. And it's very hard to kind of create these unit tests or integration tests with things that are effectively natural language. It's much easier if you have some application that you input a number and you get out a number. It's very easy to write tests around that. It's harder with something like GPT. I think similarly, there's another sort of just using AI in general, not just GPT. So for example, there are startups that are coming up using like AI-driven compression. So whereas, if you're on the Zoom call, there's like some amount of compression so that we don't have to use too much bandwidth. So on your side, the video is being compressed before it's being sent to me. And so that allows us to use fewer resources and then it gets uncompressed on my side. Historically, that's something that, some engineers would think beforehand. They would think, okay, well, like, how can we compress this in ways that make sense? And they would say, okay, well, like, maybe I'm just making up an example, like maybe there's a lot of like red pixelation, red pixels on the screen. And so let's use fewer bytes for red pixels and like let's use more bytes for the pixels that don't show up as much, those colors. So they come up with like various encoding schemes. But now that AI is kind of a thing, there are startups that are actually kind of even on the fly, just kind of creating compression schemes that humans might not even necessarily understand fully, but they're just more efficient. And if you save even like 3% or 4% of your data size just via like an AI compression algorithm, that could translate to millions, maybe billions of dollars for a company like Zoom. So I would say AI and GPT, those kinds of things are pretty interesting in the system design space right now. And then I think on the prep side, which is more my expertise, I think there's just so much to be done. There's not really any resource that I think does it all for engineers. And so engineers are forced to kind of look at a bunch of different resources, read a lot, and it's kind of vague to figure out, well, am I ready for the system design interview or am I not ready? I think hopefully with system design blog, this will become less of a problem. But I think there's just so many resources and figuring out exactly what interviewers are looking for is like still an open problem.
That's true. That's totally true. That's why I think that your job will be highly appreciated by many, many people. If we're talking about some challenges, for example, I want to learn more about system design and what kind of challenges people like me usually face as they start their path in system design.
I would say, first of all, maybe understanding the structure of a design is important. It actually kind of mimics how you would create a design doc. So if you're just starting out, I would say the first thing is, let's say you're a new engineer, is to kind of ask your manager to like that you want to create a design doc and have them criticize it. Design docs tend to follow pretty similar, they're very different. Some systems have very, very intense technical design docs, but I think they have kind of similar flows of information. So, you start out with an introduction, then you kind of, you want to gather what functional requirements you have, what non-functional requirements you have. So for example, like how distributed is it? How fast does it have to be? How safe does the data need to be? What downtime is acceptable? SLAs, things like that. And then you actually go into the high level design and then ultimately the low level design. So just understanding the flow and being very comfortable with kind of how you start a design doc and how do you dive deeper into what needs to be dived into. Because, you know, when you're starting to build a system, especially if it's a big system, you're not going to know everything that's going to go wrong. So it's, you have to just kind of do your best to address the difficulties head on, like things that you think have a very high chance of going wrong if you don't think about them up front, and spend your design doc just thinking about those hard problems. I think junior engineers sometimes try to like steer away from the hard problems, which is exactly the opposite of what you should be doing. You should be like addressing the most difficult things, because that will ensure that your project will move forward successfully. So for junior engineers, I would say just like get down the structure of what a design doc should look like, and then make a design doc whenever you can and get criticism for it. And then you'll find if you do those things, and a system design interview actually follows pretty naturally from a design doc. You know, you spend the first 5 minutes coming up with requirements for your system. Next few minutes, you come up with an API, high level design, and then you spend most of the time just discussing the low level design, which is kind of how it would work in real life to some approximation as well.
Could you please provide some explanation, like about the difference between high and low design?
Sure. So you have these kind of requirements probably. So if we take Netflix, for example, you might think, well, what does Netflix do? Netflix, you should be able to maybe search for videos. You must be able to upload videos if you're on the server side, and you must be able to download the videos if you're a person trying to watch them. So already in those functions, we notice that there are certain structures organizationally. So there's a database of videos, and then there's also a database of like search terms and keywords and things. And if you think about it a little bit, you might think, well, okay, I want to organize those in different places. Like I want to have a video database and I want to have a search term database. And it requires a bit of thinking, but then once you have these ideas, you'll think, okay, I want a service to sort of handle all of the searching that a user does, and I want another service that handles downloading and uploading of videos, just because the data is very different. That is what we would call high-level design, because we're taking the needs of the system that we need to search and upload and download videos, and we're sort of segmenting them into microservices. That's what we would call high-level design, because it doesn't really go into any of the like technical details. It's just like, this is what we want. These are how services should maybe talk to each other. Low-level design actually goes into those in as much detail as you need to go into them. So, you know, how do you actually search for things, especially if you have, you know, YouTube scale where you have, I don't know, millions, maybe billions of videos. Like, how do you actually make sure that the user can get the best result page that they can get in under a second? It's not trivial. It requires many machines talking to each other and a lot of distributed tech. So it's not trivial. And that would be kind of more akin to the low-level design. Like, another question that often comes up is, what database should we use? Financial databases will want like high consistency, because you don't want your database to be in some invalid state where, you know, someone, you know, sent you some money, but like maybe something happened in the database and like you are not seeing the right amount on your side. It seems like a correctness thing, but there are actually databases where this is totally fine. Like, for example, for Facebook, right? If someone posts something and you don't see it right away, that's like totally fine, right? It's not really that much of an issue. And in those cases, we can actually, you know, use lower computational power, and we don't get perfect correctness, but Facebook doesn't need perfect correctness. And so we can lower costs and come up with a better design. So so low level design kind of is just like like exactly how are you going to build a system, what kinds of databases are you going to use, what kinds of caching mechanisms, what kinds of, how will the data flow within your service, um, all of those kinds of questions, I guess.
So what's the most like difficult part of the system design?
That's a good question. I think it's hard to kind of say, this thing is like the API is way more difficult than something else. Because, for example, if you come up with a bad API and you need to change it later on, but let's say there are a million users using your API, it's going to be very hard to change it, right? And so you need to like get the API correct in a lot of cases. Whereas the low level design, you can kind of always change that stuff and people might not even notice. But then on the flip side, the low level design is actually where a lot of the actual algorithms live and where a lot of the things actually happen. So you might say that, well, the low level design is way more important than everything else. So I don't know if I would say that there's like something that's like more important than something else. You really just need to get everything to work out well.
Yeah. If we're talking about like the most common issues that we have like on the production, so they are related to.
Let's see. In production, I would say I feel like the majority of the bugs are probably going to be in some low level detail. And so that's actually a good point. I think probably maintainability is also a very important part of system design. If you build something that, gets you promoted, but then you never like a bunch of people work on it and it's just a pain to work on, it's going to be possibly very buggy, maybe even to the point where it just like, loses your company a lot of money. So I would say making sure that your system kind of doesn't get away from you is like an important feature. What I mean by that is like, you have a design doc that kind of starts everything, but then various engineers will work on whatever was in the design doc. It's very easy for people to just come up with implementations that break something somewhere and like some other engineer doesn't know about it. So that actual kind of consensus or communication, it's not trivial. For example, at Bloomberg, I was working on a project that had 100 engineers on it, and it's one product, right? So how are you going to know? And bugs would come in, and we would take turns actually fixing the bugs, but you don't know where the bug originated, right? Like, because there are 100 engineers that contributed to the code. So
monitoring is really important, and it's hard to manage, right?
Yeah.
I had like not an issue. I have a situation in my previous company, we have like some project that were like connected so close to each other, lots of dependencies. We have lots of issues in prod, and no one understood what's going on with our system design, with our architecture, and we didn't like support like nice and clear documentation. And it was like a mess, and no one understood what we have to do with that. No one even wanted to go deeper and try to figure out what's going on there.
Did you have like different environments? Like, so could you like roll back the release very easily from prod?
No, it was like some issues on production. I used to work with blockchain, so there were like different dependencies with blockchain as well. So for example, we lost our node for a few hours. We had also like AI engineers, and some of them just test something, influenced a lot as well, because it's like take lots of power and memory as well. So it's well lots of issues at the same time, and no one understood what's going on. How we can address these situations in the future? So is it important to keep the documentation updated, or if you want to test something, or if you want to add something, like a new feature, AI scripts, we need to like make sure first that it will not influence on other parts and services on databases, or is it a communication issue?
It's a good question. I think it's just going to be different for every team, but all of the teams that I've been on, it seems like it's almost always a communication issue. It's almost always that people are just not talking about the details of their system to other people on the team. For whatever reason, maybe they think it'll take too much time. Maybe they think, well, it's not relevant. But I think that is at the core of a lot of the issues. I think yes, it's nice to keep the documentation up to date, but I feel like a big part of being on a team is that you can just talk to someone anyway. And I found that I get so much more information from the people on my team than the documentation,
Mhm.
oftentimes. And then there's also the non-human part of it's nice to have a good CI/CD system and a lot of tests in place so that if someone breaks something at some point, some test will fail and uh, if you have enough test coverage, that should theoretically be enough to prevent a lot of these production issues.
What do you think? Who is responsible for the system design? It should be like an architect or some senior engineer. I don't know, project manager, who's going
Yeah,
to keep it up to date and to manage the whole system.
that's a good question. I think it's varied by company. I think, for example, Amazon has literally like a solutions architect title. I could be wrong, but I've never worked at Amazon. But I think even within the same company, different teams have done things different ways. So I joined an existing team. A lot of people were joining that existing team, and a lot of people were leaving from that team. So there was this migration kind of happening of people. And before I came on, the tech lead basically designed everything. And I think there was just this idea that, well, like the tech lead has the most experience, so he should be the one building things. But then I came on and my manager came on, and I think we collectively decided that, well, we have like 12 engineers on this team. It's kind of a waste of time for one person to be doing all the design. We should just like let people make their own designs and then implement their own designs. Different people will do different things. I preferred the latter because it doesn't make that much sense to me to have a junior engineer work for like a year or two and not give them any design work because they're a junior engineer. It just seems like you're not really helping them grow when
Mm.
design is such a huge part of it all. So I'm sure like different companies have different ideas. Maybe there's this idea of like an architect that should maintain everything and make sure the document is up to date, documentation is up to date. But I generally feel like we should decentralize design as much as we can, probably. Like it's better to have, especially for big systems that many people are dependent on, it's useful for a bunch of different minds to be thinking about the design and keeping it up to date because, yeah, you don't want, I think, a single point of failure in terms of just like having a single architect.
Cool. I like this idea. I like this idea. So it could be like some of brainstorming sessions with the team, right? Or just like kind of meeting, we can discuss and share our opinion on that and make decision together. It's cool. I like it.
Yeah.
Okay. Let's talk a little bit more about the interview process. What kind of advice would you like to give the people who want or who are in the process of preparing for system design interview?
Oh, advice is so general because I mean I could keep
But
it as general as do your best or something. I would say just like don't get worried because it's going to seem scary. Like someone's asking you to build Uber and you don't know how to do it. And I think the first thing is to not be afraid because plenty of senior engineers have gone from knowing nothing to knowing a lot in like a month or 2 months or something. Um, I think the other thing that is kind of useful to know is there are about like 30 canonical designs, maybe give or take, that if you learn them,
Mhm.
you'll be able to like adapt them to any given situation. So, search engines, like a video streaming service, Uber or something where there's like a very write heavy sensor kind of thing where the cars are just always streaming data to the Uber's central servers. Um, Log aggregation, and there are a few others, right? But it can seem like a lot to someone who's never um, got into it.
Yeah,
It seems like
exactly.
there's like an infinite number, right? And there kind of is an infinite number because you can always just tweak the problem slightly, but there are really like only 20 to 30 things I would say that you need
Mm.
to like see and like kind of understand. And then that puts you in a very good place to actually like go into an interview and feel confident that, oh, I've seen a system that looks kind of like this one. But it's not instantaneous. You're not going to get that like in the first week, right? It's going to take a bit of time, and you're going to have to do some legwork figuring out what those 20 to 30 systems are. Hopefully System Design Blog will like give those to you, but that is a part of it, right?
Yeah, I think that I have another advice on that. So if you're preparing for example for a Google interview, so you have to look into their products and you have to understand how their products look like and work. You can share your experience in the past, but most of the company, as I understood, they will ask about their products or something related to their products.
Yeah, I have an interesting story here. So I think I was working with a autonomous, like I was interviewing at an autonomous vehicle company, and they asked me basically like an autonomous vehicle type question, which was essentially like, well, we have these vehicles, they drive themselves. How do we, I don't remember exactly. It was like, how do we know where they are? Or how do we know, like, we want some data about like their location. And it was like very similar to Uber, right? Because like Uber does essentially the same thing. It's like a bunch of cars moving around and like transmitting data. So knowing that, you could look at the question and be like, oh, this is like very similar to this other question. I think what I've experienced is at smaller companies like startups, they tend to ask you questions that are like specific to their products. But I've found at bigger companies, I've often found that they just ask you like a wide spectrum of things. Like for example, Google has a million products. And so they don't always ask you just like, well, how do you build Google search? Some people will ask you that, but I found that they just like, I'm sure there's some leeway the interviewer also has to just ask you whatever question they kind of want to ask. There's like an internal database that has like hundreds and hundreds of questions, I'm pretty sure, at least for coding. And I don't know that much about the system design collection, but that's been my general experience.
Yeah, I totally agree with you. Of course, yeah, if it's a huge company, so it's impossible just to learn everything they have. And definitely they won't like ask you just the most obvious like questions like search engine or something. So it's gonna be something more complicated and unexpected. Okay,
Yeah.
so if I want to start from scratch my preparation process, how long it will take? 1 year, 8 months? 5 weeks.
I guess it depends. You need to tell me more about your background.
For example, I'm a software engineer for level, but I didn't have experience in system design or had, but a little.
And it's important to be able to talk to someone with confidence and not be nervous thinking you don't know as much. So I think that probably takes a lot of time to get that confidence. And so I'd expect that you kind of have that. And so now it's just like, well, how do you get the knowledge that you can actually, use this confidence to talk about? I would say there's kind of like the current paradigm, and then there's like what I'm hoping will happen. So I think in the current paradigm, there's kind of like, and it also depends on if you want to apply for a senior role or a staff role. They're a bit different. I think if you want like oh, sorry, go ahead.
Yeah. My next question is what's the difference? I mean, in terms of system design interview.
Yeah. So I guess I'll answer this first question of like, I think seniors probably like, if you're a senior engineer and you want to kind of be prepared and you have, let's say like a few hours each day, maybe like 2 or 3 hours each day, I would say I've observed a lot of people take 2 to 3 months to get like their baseline preparation down. And then I think the people going for staff have to spend a little bit more time, unless they're particularly, I think if they're very interested in system design, that can like cut down some of the time because they just like maybe think about it all the time. But yeah, staff will take more time because you have to dive deeper into concepts.
Yeah, to be honest, I've heard some stories like people preparing 1 year in order to get a job, Apple, Google, Amazon, so on. So it's not like short period of time. It takes months.
Yes, it definitely takes months. I can definitely see someone taking a year. But I feel like those people, I think the reason you would take a year is because it's unclear when you're ready. If there were
Mm-hmm.
it was just a checklist of like you need to know this, this, and this, then I
Mm-hmm.
think people would be more driven to hit it earlier. But the fact is there
Mm-hmm.
is no checklist of like, oh, you know these things, okay, go for the system design interview. It's and you know, if you don't pass the Google interview, you have to wait 9 more months, right, to take it. So
Yeah.
it's there's like this trade-off of like, well, how much time are you going to spend? Because you only kind of get one shot a year.
Yeah, you mentioned like checklist, so I think it will be really, really helpful. Maybe you have to create this checklist.
Yeah, hopefully. I mean, that's kind of the plan.
That's a nice idea. Yeah, tell me a little bit more about what's the difference of expectations if you just like, for example, you have interview and this is just a staff engineer or it's a senior engineer. It will be like more complicated system and or application, or I just expect that your answers will be like deeper. Or what's the difference of expectations during the interview?
Um, yeah, I think depth is the main thing. So you need to be, I think a lot of companies, Google, I think Meta as well, they will, you know, you'll have an interviewer and they will have to say like, it's not just yes, no. Oftentimes nowadays, it's like, which level as well do I recommend this person for? So the question is then, well, how do I get the like higher level? And I think depth is the main thing. Like one piece of advice I've heard is that if someone gets the L6 offer, or sorry, the L6 level for an interview, um, it's it's often the case that that person teaches the interviewer something, because the interviewers are often like L6s themselves or something, and you often have to like tell them something low level, which um, can seem really hard to people. But if you've spent like months and months like learning about all sorts of system design things, I would say like realize that your interviewer has not spent that much time doing it. And so they're just like, you know, it's a work day for them. They're coming to interview you. And it might not be as scary as it seems to like teach the interview or something. Like actually, because if you're studying all of these different things in software engineering, you'll start to realize connections and things, and you'll start to be able to just say like, oh, it's useful to have an LSM engine here instead of like a B tree based engine, or you'll be able to like tweak whatever this what is the word uh, I'm blanking on the word for when like SS tables get compressed. Maybe it's just called compression. Or here's a sparse index that we can use. Or here's how Redis uses their eviction strategy for their cache. Right? Like there are all sorts of things that you'll pick up as you learn, and you'll just be able to like talk about it, um, almost conversationally. Right? And I think when I went into these interviews, I expected it to be a lot harder than it was to like I expected like the interviewers were out to get me and like they would be very, very stingy with these like L6 levels. But then as I prepared, I found that if you can speak reasonably deeply about, you know, any of your system design topics, then your interviewer is kind of often on your side and like oftentimes pretty friendly. And they honestly like want you to kind of succeed. And so I think they're usually having a pretty pleasant conversation with you. Um, but yeah, I guess I forget what the original question is, but I think depth is probably the main thing that would like distinguish an L5 from an L6. Being able to cite specific details, perhaps design specific details, like particularly for, you know, Twitter, you know, maybe you say like specifically this requires a fan out architecture or something. And being comfortable with those terms, I think is important.
Yeah, cool. I like this point actually. Okay, so maybe any other kind of tricks, life hacks, and advice on how to successfully pass this design interview?
So I'm still working on system design blog, but a couple of the things that helped me kind of get to this point were probably there are a few high level design resources, I would say. There's like
Mhm.
Grok the System Design Interview, which is an online resource. There's Alex Shu has a book called, I think, How to Approach the System Design Interview or something similar. Um, I I mostly used grokking for the high level, and I used uh, the design of data intensive applications, DDIA, for as sort of like a more comprehensive reference book. In fact, a lot of people going for staff level are told to spend 6 months just absorbing everything that's in this book.
Mhm.
Um, I think there are only a few, like, not every chapter in that book is as important as every other chapter. So I would say there are maybe like 3 or 4 chapters out of the 12 plus chapters that comprise 80% of what will show up in your interview. So it's actually not as tricky to read as it might seem initially, but you will have to adjust to it. It is a bit more complex than software engineers are normally used to, I think. But I think those resources really can teach you a lot. And I think there are various YouTube channels that are very helpful. InfoQ is one I remember where there were a lot of tech talks being given on actual systems being used in production that had interesting
Mhm.
system designs to them. So um, I guess I'm just mentioning different resources. Everyone's going to have a different set of resources that they resonate with. But yeah, what we're trying to do with the blog is kind of bring them all together so that engineers can save time and uh, I guess do better in their interviews.
So let's summarize. So first of all, it's better to know the theory, right? To read books, different blogs. Now also look at some examples. And you mentioned mock interviews. It will be helpful as well. And do you think it's a good idea just to create like new applications by your own?
A lot of people think about this, and I think my personal opinion is that you'll see a lot of very senior engineers who have been doing things for like 10 or 20 years, and they'll say that, well, like the way that you prepare for software system design interviews is that you just get the experience from building things, and you just remember that, and then you go into the interview and you do it because you know how it works, so you do well. I tend to disagree with this just because I
Right.
feel like there's so many things that you can ask about in a design interview, and it's kind of unfair to say, well, the reason you did poorly is because you didn't design a system. It's usually not that. Like, most engineers don't know about most systems by default. They need to read. They need to actually actively pursue that knowledge. And
Mm-hmm.
so you could be such a senior engineer and you could still not know how a search engine works because you've just never worked on it.
Yeah.
So there's no shame at all. You should be studying things and you should be reading things that you don't know. Um, and I didn't mention mock interviews, but you mentioned it. So I'll say, like, mock interviews are also incredibly helpful. I was lucky enough to have a few previous managers and mentors that were like always kind of interviewing me to keep me warm. And I found that so helpful because I would go into an interview with a company that I wanted. And for the past like day or two, I would have had an interview each of those days by one of my colleagues or friends. And it made it seem like this isn't a big deal. This is just like something I've been doing for the past X days.
That's the next step for your personal development.
Um, it's hard for me to kind of, every path is different because everyone's background is different. I think for me, I I don't really know where I'll be in a year from now, but I know what I'm doing right now and I know why I'm doing it. And I think that's probably useful for people to know. If if you don't know why you're doing something, you're not learning anything, or you're not, you think about it and you just don't know why you're doing it, I would encourage you to rethink it. Um, I would love for System Design Blog to become kind of my full-time work for the next, like, how many ever years. If it seems promising right now, and if there truly is a need in the market for it, then it'll do well. And if there isn't, then it won't do well. And either way, I get an answer. So
Oh,
I'm going to work on it for the next year or so, hopefully, and see whether or not people actually need this resource or not.
oh, thank you. Thank you very much for your time.
Of course. Yeah, thank you so much for having me.
Yeah, I wish you a wonderful rest of your weekend.
Okay, well, thanks, Senia, for interviewing me. It's been fun.
Yeah, thank you. Thank you very much.
I'm waiting for it to have like 100,000 subscribers.
We're working on it. Thank you for contribution.
All right, take care.
Okay.
Bye.